Welcome to a new lesson. In the previous lesson, we learned the details of shuffle and sort execution. In this lesson, we would learn about a few performance tuning features in Hadoop. First, we look at speculative execution. The advantage that Hadoop has is that it breaks the tasks into smaller tasks and processes them in parallel. This parallel processing gives Hadoop advantage over the conventional single node processing, and so Hadoop can produce higher throughput. But in case if one of its tasks performs poorly, the performance of the whole job goes down. In this simulation, you can see that the task 3 has fallen behind the rest. This can be because of hardware degradation or software misconfigurations as well. In those cases, Hadoop relaunches the task to another machine. The one that would finish first would be taken for the result and the other one would be killed. There are these two important key points that needs to be kept in mind when thinking of speculative executions. First, speculative tasks are only launched after all the tasks of the jobs have been launched. Job tracker then monitors if there are jobs falling behind, and then only it would speculatively re-execute a task. Second, it is an optimization feature and not a reliability feature. What it implies is that if the task is running slow because of a bugsy code, Hadoop won't be able to fix it or diagnose it or pinpoint error on the code. It is just ensuring that the underlying hardware and software configurations are not the reason for the slow progress of the task, and so it would try to run it on a different node, so that the whole job finishes as quickly as possible. Either of original task and speculative task can finish up first. As soon as one finishes, the other one is killed. Properties in regards to speculative executions are mapred.map.task.speculative.execution. This is the property for map tasks. Then mapred.reduce.task.speculative.execution. That is for reduce task. These are Boolean properties which are by default set to true, which implies speculative execution is enabled by default. These properties are recommended to be set to true, but they can be set to false as well, thus not allowing speculative executions. This would be done only in the case if the cluster is already overloaded and we need not overload the resources with speculative tasks. Some installations prefer no speculative execution on reduce side. It is done so because to start another copy of reducer, the map outputs would be needed to be fetched from the network, which would considerably increase the load on the network. Next, we look at another feature, that is task JVM reuse. This feature can be used for performance gains in case if there are a lot of small jobs. For smaller jobs, the overhead of launching a new JVM is significant. The tasks run on a different JVM so as to segregate them with the long-running system daemons. Reason behind it is that the user code has a high probability of being erroneous, and in that case it may disrupt the system daemon and hence the JVMs are separated. The tasks which qualify as small tasks are known as Uber tasks in Yarn, and they are launched and run on the same JVM as application master. In case of MapReduce1, the task tracker shares the JVM with map or reduce task. The property mapred.job.reuse.jvm.num.tasks decide on how many tasks can be run on the JVM. 1 is the default and -1 can be set to indicate there is no limit to reuse the JVM. The next feature we look at is skipping bad records. There can be a situation that the task may be failing because of the data issue rather than a code issue. When the input data is large, that situation is not likely to happen. For this reason, your program should be designed in such a way that in case if it receives a bad record, it should not process it, but rather handle it through exceptions. And a counter should be maintained to keep track of how many such records have been there. Counters would be discussed in a little more depth in the next segment of this course. So you have designed your code to handle the unexpected situations, but still there can be a record with data not handled by the code. It has been analyzed and observed that there won't be many of such kinds of records, but there would be only a few which would cause the task to fail and thus the whole job to fail. To handle such situation, MapRed framework has a feature of skipping the bad records. Let us understand how it works. Let the lines signify the input records in the input splits, with blue lines as good records and red line as bad record. The task tracker would process all the good records to produce key value pair. As it reaches the bad record, it would fail. Observing this, job tracker would relaunch the task on another machine to ensure that underlying hardware or software configuration is not the error causing issue. The task would process all the good records and would fail at the bad record again. And again the job tracker spawns the task on a new task tracker. This task would again process the good records, and when this fails, it sends the record on which it has failed, and skipping mode is enabled by the job tracker. Now on the fourth attempt, the task processes the good records, and when it reaches the bad record, it would skip it and try the next records and continue processing it. So there are 3 failures before the skipping mode is enabled. It is designed so because if every failure of task tracker starts to communicate the record on which it has failed, it would cause 2 potential issues. First, a lot of network bandwidth would be utilized to communicate the record information. Second, the job tracker would be loaded with a lot of data of failures, and it would get difficult for the job tracker to keep track of all the records. So if you want to use this feature effectively, you would like to increase the value of maprate.max.attempts and maprate.reduce.max.attempts, which control the maximum number of retries on map or reduce tasks respectively, as we had discussed this in an earlier lesson. The default value is 4. This wraps up our discussion regarding these topics. See you in the next lesson.